10. 5G RF Engineer Interview Questions and Answers. Question 1. Key differences between 4G LTE and 5G NR. Answer. Spectrum. LTE mainly uses sub-3 GHz, while 5G uses both FR1 sub-6 GHz and FR2 mmWave up to 52.6 GHz. Bandwidth. LTE max is 20 MHz, carrier aggregation up to 100 MHz, while 5G supports up to 400 MHz FR2. Architecture. LTE is EPC-centric. 5G uses service-based architecture, SBA, with flexible core 5GC. Latency and speed. 4G 10 milliseconds latency. 5G can reach 1 ms and multi-GB speeds. Question 2. Frequency bands and mmWave challenges. Answer. FR1 sub-6 GHz, 410 MHz to 725 MHz, better coverage, moderate capacity. FR2 mmWave 24 GHz, 52.6 GHz, ultra-high capacity, short range. Challenges of mmWave: high path loss, poor penetration through walls, glass, foliage, requires dense small cell deployment, and beamforming for reliability. Question 3. Massive MIMO and beamforming imaging. Answer. Massive MIMO uses dozens to hundreds of antennas at the base station, improves spectral efficiency by spatial multiplexing. Beamforming focuses energy toward users instead of broadcasting everywhere, improves CNR, reduces interference, and extends mmWave coverage. Impact: higher capacity, better coverage, efficient spectrum use. Question 4. 5G frame structure and numerology. Answer. LTE has a fixed 15 kHz subcarrier spacing, SCS. 5G NR supports scalable numerology, 15, 30, 60, 122, 40 kHz. Slot duration shrinks with higher SCS, e.g. 1 ms at 15 kHz at 0.125 ms at 120 kHz. This flexibility allows low latency URLLC and high throughput EMBB in the same network. Question 5. RF planning challenges in 5G. Answer. Urban areas, dense small cells, interference management, building penetration issues. Rural areas, limited spectrum availability, large cell radius but poor mmWave feasibility. Overall, balancing coverage versus capacity, site acquisition, and ensuring spectrum efficiency.
Question 6. Link budget analysis in 5G. Answer. Same principle as LTE. Text power plus antenna gain minus path loss, penetration losses, equals RX power. New 5G considerations. Higher frequencies, higher free space path loss. Beamforming gain can improve link budget. Indoor-outdoor penetration becomes critical, especially in FR2. Question 7. KPIs for 5G RF optimization. Answer. Coverage KPIs: RSRP, RSRQ, SINR. Quality KPIs: BLER, CQI. Capacity KPIs: throughput, DLUL, PRB utilization. Mobility KPIs: handover success rate, call drop rate. Tools: TEMS, NEMO, ACTX, ATOL, MapInfo, etc. Question 8. Scenario: poor coverage in mid-band. Answer. Troubleshooting steps. 1. Check RF parameters: TX power, tilt, azimuth. 2. Verify antenna configuration, feeder issues, VSWR, connector losses. 3. Analyze coverage maps and drive test data. 4. Adjust RF planning: antenna tilt, power, add repeaters, or new small cells if required. A. Question 9. Managing interference in 5G. Answer. Use beamforming to focus energy and reduce spillover. Frequency reuse planning, example, tight reuse in TDD. ICIC, EICIC, final, COIMP, coordinated multipoint techniques. Proper PCI, physical cell ID, planning to avoid collisions. Question 10. Smart City 5G deployment, RF considerations. Answer. Spectrum strategy. Use mid-band 3.5 GHz for wide coverage, mmWave for hotspots, stadiums, downtown. Site density. High density of small cells, especially for IoT and smart traffic. Antenna solutions. Massive MIMO, beamforming. Special cases. Indoor coverage, malls, metros. Street furniture, lamp posts, bus stops for small cells.